Ready to go? All right, we'll start again. Hi, everybody. Welcome to my talk. Today I'll be presenting 10 commandments for writing spiffy Lightning apps. My name is Anup Jadhav. I'm a freelance technical architect and Force.com MVP. I've been building Salesforce applications for the last 8 years now, and I've been working with Lightning components for the last 18 months. So these are some of the best practices that I've collected over the last few months. So I've got like 40 slides to go through, so probably we won't have questions for Q&A, but please feel free to grab me if you have any questions after the talk. I'll be around here somewhere. Okay, so let's jump straight into it. Commandment 1, learn JavaScript. Put your hands up if you understand all of these concepts here within the context of JavaScript. Immediately invoked function, expression, closures, prototypal inheritance, variable hoisting, promises. Okay, I've got 1, 2. Okay, cool. So these are, well, I've deliberately chosen some of the advanced concepts here, just to show you that JavaScript is quite a nuanced and a complicated language when you actually try to learn it. Most of us I suspect, come from Java, .NET, C# background. We've used JavaScript in the past, maybe as a glue in Visualforce, or maybe we used a library like jQuery to build applications, but we've never built a big applications using just JavaScript. JavaScript is quite an interesting language, and having a deep knowledge of this language is a useful skill to create elegant and fast Lightning components and Lightning applications. Sorry, I have to stand here because I've got a USB-C connector and I don't have a clicker because there's no USB port for me to use a clicker. If you want to learn or relearn JavaScript, here are some of the resources that I'd recommend. The first resource is this article called JavaScript Reintroduction to JavaScript on the Mozilla Developer Network. It's a great resource for people like us or some of us who've used JavaScript in the past but would like to understand JavaScript properly. The second resource is an online book, which is available for free, and you can also buy the hard copy version of it. It's called Eloquent JavaScript. The good thing about this resource is that you can try the code inline in the browser. And if you really like to understand the guts and internals of JavaScript, I'd highly recommend this series, You Don't Know JavaScript by Carl Simpson. It's available free on GitHub. Again, you can buy the hard copy online. And finally, this final tip is very useful because I found it very useful to read JavaScript code written by front-end developers. So true story, I created a pull request. I wrote my first Lightning component, which was quite complex. I created a pull request. I was quite happy with it. And then the person who reviewed the pull request was an AngularJS developer, and he rejected it. He said that the code works correctly, but you write like a Java developer. And I was quite offended. It's like, what does that mean? It's like, you'd think like a Java developer and you write JavaScript like a Java developer. And then he rewrote some parts of it, and he reduced the 200-line code to around, I think, 70 or 80 lines of code. And I could see that he was using stuff like closures and all some of the other stuff like promises and everything. It made the whole application faster. So I'd highly recommend reading JavaScript code written by hardcore JavaScript developers like maybe AngularJS developers, or I think there's some of the developer evangelists. I forget his name. But you'd find some online code for Lightning components, and I'd recommend reading that. I will find the name later and probably post it. Yes, thank you. What's his full name? Conrads, yes, that's him. Thank you. All right, so that concludes Commandment 1, learn JavaScript. Commandment 2, forget MVC. Well, not really. Again, we as Java, .NET developers, we've built applications using the MVC pattern. Even Visualforce follows the MVC pattern. But is Lightning components an MVC follows the MVC pattern? No. Lightning component follows a variation of MVC. It's more like view controller model pattern, which is quite common. It's called MV star or MVVM pattern as well. So this dual controller design is the main difference between Lightning components framework and a typical MVC framework. Lightning component app bundle has a client-side view. It has the client-side JavaScript controller and helper. It has server-side Apex controller and server-side model. So MVC is not, I'm not saying MVC is a bad pattern, but it's useful to have this conceptual model in your mind when you're building Lightning components and apps. Another way of thinking about this is that you have, in Lightning components or Lightning apps, you have a thick client and a thin server, so most of your business logic will reside on the server side. Okay. Commandment 3 is support accessibility. I know it's not in the top 10 list of every developer to think about accessibility, but accessible software and assistive technologies enable users with disability to use and interact with your product effectively. And it's very easy to support accessibility. Aura components are created according to W3C spec, and follows the web content accessibility guidelines. So here are some of the tips for making your app more accessible. Set the label attribute when it's available. So here are some of the components where the label attribute is available. It's useful for assistive technologies if you set the label. Use the ARIA described by attribute to associate the help text with a particular label, component. So in this case, I'm associating this output text, which is, this is an example. I'm associating that with this input text. So when an assistive technology reads that, it will know that this text is linked to this input text, and it could give helpful input to the user. You can also convey audio notifications. Anything that's inside UI message will be conveyed as an audio notification by an assistive technology. And finally, this is one of the best practices to make your app more accessible or a component more accessible. Always consider attaching on-click event to elements that are actionable in HTML. So rather than attaching on-click events to everything, try attaching it to stuff that's actually actionable, like anchor tag, button, or input tag. Okay. Commandment 4. Sorry, I'm going very fast. I've got a lot of slides to go through. But if you do have any questions, please save them for the end. And if we don't get time, please ask me afterwards. So, event propagation. So the framework follows event-driven programming. You write handlers to tackle events that may or may not arise from user action. So you have two types of events. You have component event and you have application event. Component event is fired by an instance of a component. It can be handled by the component itself or another component in the containment hierarchy, and it supports capture and bubble phase. Are you familiar with capture and bubble phase yet? It's quite recent, I guess. So capture phase is the event handler is invoked at the application root, and if you have any nested component, the event handler is invoked from the application to the source that fires the event. And bubble is the exact reverse. The event handler is invoked by the component that fires the event, and then it bubbles up to the application root. For component events, bubble is the default phase. But if you want to change the phase, you want the application root to handle the event first, you should set the phase type to capture. So this is an example of component event. Application event, as you'd guess, follows it happens at the application level, so it follows a publish-subscribe model. Again, it's fired by an instance of a component, but the handler doesn't have to be within the same containment hierarchy. It can be part of another subtree as well. It supports capture and bubble phase, but it also has a default phase, which basically means the framework can invoke event handlers in a non-deterministic manner. So if you don't care about events being captured within the same subtree, default phase is useful if you have handlers across subtrees. Okay. So some of the best practices for event propagation: always try to use component event instead of application event, because component event is handled by the component itself and within its own containment hierarchy, so its usage is more localized, and only the component that needs to know about the event handles it. Application event should be used in two scenarios, I think, in my view, when you have handlers across containment hierarchies, i.e. the components are not in the same hierarchy, or for events that should be handled at the application level, like navigating to a specific record or something like that. Firing an event in a renderer can cause infinite loop, so don't do that. It's an anti-pattern. And this is the best practice, also creates maintainable code. Try to separate low-level events from business logic event. So you can handle a click, but then refire it as a business event, like approval change or something like that. So that'll make both your code readable and also help you with error handling, which we'll talk about later. So the last best practice is around if you have a lot of event handlers listening to an event, it might be better designed to create a dispatcher event that listens to that. You have one dispatcher event that listens to that event and handles it, and then based on some logic, assigns it to different event handlers. So rather than having lots of event handlers listening to one event, it's better both in terms of performance and also in terms of maintainability to have a dispatcher event handler. Okay, and then relay those events onto other event handlers. Okay, so commandment 5. Prefer SLDS over other CSS frameworks. This one should be obvious, especially if you're using Lightning Experience. So Salesforce Lightning Design System is a CSS framework, very similar to Bootstrap if you used Bootstrap in the past. It has a semantic and accessible component markup. It has cross-browser compatible CSS. But apart from that, it also has icons, fonts, and follows Lightning user experience design principles. Why would you want to use it? Well, the first benefit that you get is by using SLDS, it automatically matches the Lightning Experience UI, so you don't have to do any extra work around that. It follows modern design standards and best practice because it's created and maintained by the Salesforce UX team. When the framework evolves, you get the benefits immediately. You don't have to do anything extra, so that's another reason for using this. It styles your component to be more accessible. So we talked about accessibility. So using SLDS makes your component more accessible. And it makes your component and app responsive. So you don't have to worry about your app being responsive on different device sizes and screens. OK. Next commandment is use base Lightning components. I guess that base Lightning components is quite new. It was just recently introduced in Winter 17 release. And basically, these are new out-of-the-box components provided by Salesforce. The reason for using them, well, first reason is you don't have to implement your own component. Base Lightning component should give you the functionality that you need. It incorporates SLDS markup and classes, which is the Lightning design system, so you don't have to do any CSS. And it handles the details of HTML and CSS. Here are some of the examples of base Lightning components, button, select. But this is not a complete list. You can find the complete list online. But these are some of the common base Lightning components that I've used. So why would you want to use it? It's easy to adopt. It's patterned after HTML standards. Like I said, it's styled using SLDS, so you don't have to add any extra CSS to it. Better performance because it's native to the platform. It's better performing than any custom component that you might write. Again, accessibility is baked in. It follows the WCAG 2.0 and Section 508 standards. And finally, it streamlines Lightning development. It speeds up your Lightning development. So rather than you spending time creating these components, it's just available for you. Next commandment, security. Secure your components. This first item around how to secure your component is kind of big deal because if you've been using Visualforce, security is kind of baked in. Visualforce respects FLS and CRUD in most cases. Barring a few. But Lightning components don't automatically enforce CRUD and FLS. So you have to be very careful when you create your Apex controller, for example. So you have to manually enforce it. So for example, in this case, I'm getting a list of expenses. This method is vulnerable because even if the user does not have access to the amount field or client field, or they don't have access to records, they might still see it. Okay, so components don't enforce FLS and CRUD. This would be a better way of implementing this. So what you would do is you would create an array of all of the fields that you want to check. Then using the schema API, get a map of all fields, loop through the fields and check using describe, check if it's accessible. And if it's not accessible, throw this exception. If there's no exception, then run this query. So it's a bit of a work, but it's better to do that. Otherwise, you might end up exposing data to unauthenticated user, unauthorized user. The next step is, well, Lightning components. The framework supports CSP to control the source of content that can be loaded on a page, which basically means that all JavaScript libraries should be uploaded as a static resource. So you can't just use a CDN. You should upload it as a static resource. That same thing applies for fonts, external fonts, images, frames, and CSS all must use HTTPS. The last thing is CSP is not enforced by all browsers, so you can check can I use.com to see which browser supports CSP. So something to be aware of. And finally, well, not finally, local service. Local service is your friend. So local service will break your application, but treat it as your friend. It'll break your applications right now because it was introduced after you built some of your components or something. But local service is your friend. It does a couple of things that will ensure that your applications, your components secure. It tightens CSP to eliminate all of the cross-site scripting attacks. It disallows some unsafe keywords. So the impact here is it's not only your own code that you have to be wary of, but also any third-party application libraries or JavaScript code that you're using. Make sure they're not using any of these unsafe keywords. It enforces ECMAScript 5 strict mode. So in strict mode, there are some benefits of strict mode. First one is strict mode. The first one is JavaScript won't fail silently if you don't declare a variable, which is quite common, where you use my var in camel case, but then you use my var all small case somewhere else, and then spend 2 days figuring out what's wrong with the application. ECMAScript 5 will throw an error by detecting that. DOM access containment means that a component won't be able to access DOM across components or across its boundary. It will contain the access within its own DOM component. Restriction to global references. So global objects like document or window. Previously, I think you would you would have called any method on those two objects, but local service locks that down, and you're only allowed to call certain methods on those global objects. And finally, because Aura is open source, you can just look at the source code and see all of the methods, and you can say, oh, I want to call that method or this method, even though it's not part of the official API. So local service puts a stop to that. It just supports all of the API framework methods only. So if you try to call a method that's not part of this, it will break your application. And it will be activated for all orgs in summer 17 release. So make sure your app's compatible with local service. One way of doing that is by installing this CLI. It's called Salesforce Lightning CLI to validate your code. So again, we wrote our code, and just 2 days before deployment, we decided to run the CLI. Not a good idea. Came with loads of errors. But most of them were don't use console.log, so we were good. But yeah, if you run CLI, you would see errors like this. So for example, it's warning that I've got a missing radix parameter here, so I need to put an extra parameter at the end of parseInt and stuff like that. So by running the CLI, it will flag most of the problems that will make your app, that won't make your app local service compatible. Okay, commandment 8. How to avoid performance bottlenecks. So here are some of the tips. This is not a complete list, but some of the things that that I found hurts performance. So the first one is don't use RF if you can. Don't use RF to toggle markup visibility. Use CSS instead. It hurts performance and also sometimes creates bugs, hard to detect bugs. Leads to cluttered markup. That's harder to maintain. So I'd recommend using CSS if you can, rather than using RF to toggle markup visibility. Yes, this is not, well, this is something we all, we've been there. We see warning messages logged in the developer console. This is the output of the developer console for one of the components that I was working on. And we ignored it for a while, and until it reached UAT, and the customer complained that it was slow, and they were like, okay, fine, we'll look at it. No, not really, not true story, it's a joke. So don't ignore the warning messages. Sometimes trying to tell you something useful, try to fix them if possible. So review the warning messages that are logged in the developer console. This is, again, very new. I think it was recently released, unbound expression. So use unbound expression instead of bound expression. So I think we're quite familiar with bound expression, which is curly brace, exclamation, and the variable name. So what you would do is you'd have a parent component, which has its own attribute, parent attribute, and a child component with child attribute, and you're passing the value of parent attribute into the child attribute. So this is quite common. We've used this in Visual Force. Basically, this passes the value in here. But using bound expression, you create a bidirectional binding between the two. So any changes to this parameter affects this. Any changes to this change in value to this parameter affects this. But you don't need that functionality all the time. What you need is sometimes you just need one-way binding. Plus, bidirectional data binding can affect performance and also create hard to detect errors because of nested components and stuff. So sometimes you just want the data to pass from parent to child. In those scenarios, you'd use unbound expression, which decouples the bidirectional binding. Okay, which is, and the way you use unbound expression is by using a hash instead of an exclamation mark. Okay, if you use an unbound expression, it behaves just like how JavaScript would behave. All of stuff like string will be passed by value. So if you pass parent attribute to child attribute, and if you change the attribute in child, it won't change the attribute back in parent. And most of the times I've seen that I don't need that changed value back in parent, but it depends on the use case. Okay. Another tip, which is similar to the first step, which is avoid looping in the markup. Loop in the JavaScript of Apex controller. So if your business logic says loop for components or create something, create the data set in the JavaScript of Apex controller, and then push that to the front end. Okay, use app cache to speed up your app cache or application cache will speed up your app's response time and reduce your server load by just downloading files that have changed. It's disabled by default. You can set the app cache equals true attribute on the or application tag to enable it, but don't do it during development, because during development your resources will be constantly changing. It also generates the cache manifest automatically at runtime. Enable it just before deployment or during development. All right, until. Right, final tip, install the Lightning Inspector extension, review the performance tab, look for longer and deeper portions, see where performance is being affected. And this should be at the end. Don't worry about performance right at the beginning. But if you think that your app's slow, you can use the Lightning Inspector to review where which component's taking more time, or which part of the business logic is taking more time. All right, error handling. Well, it's JavaScript. You will write erroneous code, not deliberately, only because JavaScript is an quote-unquote interpreted language, and the IDE support for detecting stuff like whether variable is not declared or other silent errors is not good. So there'll be type errors and typos that fail silently, and you can have system errors because of insufficient input validation. With Visual Force, the input validation was tightly coupled, so you could do that. But with JavaScript, because it's decoupled, you need to do there might be system errors because you haven't checked whether the first name was entered or not. Okay. So best practice, use try catch in your controller and helper. And I must say, I haven't seen anybody, well, at least the code that I've read used online who've used try catch. But I'm sure people are using it. Validate your input. Again, this goes back to this issue. Validate your input. Don't assume that your input will be checked at the Apex level. Make sure you check it in the front end and give a user-friendly error message to the user, and log the actual error in the browser. User does not want to see null pointer exception. So here's a try catch example. So this is a method in the JavaScript controller. So I'm just trying catching, and when I catch the error, I just log the error in the console, but I set a view attribute to some user-friendly message. Okay. Validator input. So this is an example where I validate first name field and last name field. So I just take the contact first name value, the field, and then I check whether it's empty or not. If it's empty, then I set this to false, and then I return that. If this is false, then I show an error message to the user. Okay. Commandment 10. Unit test your JavaScript code. Platform, well, we all know as Apex developers, platform enforces Apex code coverage. You have to have 75% code coverage, any means possible, but you have to have that. No requirement to unit test JavaScript code to deploy, but that doesn't mean we shouldn't test this. Well, why should we unit test? With Lightning components, you would be writing a lot of JavaScript code. In fact, from what I've observed, again, this is not accurate stats, it's just my own personal experience, 60% plus code will be in JavaScript. The other reasons for doing testing is applies to everything, improves code quality, can catch bugs early on during dev, and ensures correctness. Okay, that's done. How do I test Lightning components? Salesforce has plans to release, I read this somewhere online, so it must be true, safe harbor. They have plans to release a testing framework, but no idea when or whether that will happen, so safe harbor. But I did find a very good tool called Grease Tool, written by Steve Buikhuizen. Apologies, Steve, if you're watching this, if I've not pronounced your surname correctly. But it's basically a Selenium test written in Lightning flavored JavaScript. The test scripts are built using chain of promises. But the good thing is it does end-to-end testing for Lightning components, so I'd recommend that you check this out. And finally, I didn't have time to show you examples for this, but there's a test framework. You can also use test framework like Jasmine or QUnit. There's a talk by Bob Buzzard, Q Bowden online somewhere, if you Google it, and you'll find more information about that. That's it. I'm done. Thanks, everybody. Do we? 2 minutes? OK. Oh, we're done. So I've been told we're done. Sorry. So if you have any questions, come and grab me. And yeah. So thank you. Thanks, everybody.